nothing better than a crispy ironed cotton shirt. But what has this shirt got to do with this ship's rigging? Doesn't look much, does it? A few pieces of fluff, really. But this, cotton, kick-started the whole Industrial Revolution. That's quite a claim, isn't it? But still, it's not a shirt yet. First, it needs to be spun to create a yarn, and therefore all the cotton fibers, the individual threads or staples, need to be straightened out or brushed in the same way, if you like. And for centuries, this was done by carding, using these carding brushes. All this carding was done in the home by women and children using cotton imported from India. Then it needed to be spun. And again, for hundreds of years, they used something very simple like this, a drop spindle. Now, it may look simple, but it's really hard, slow work. Well, first, you draw out a little bit of fiber from the cotton, and then what you do, you drop the spindle. That's why the name drop spindle. You drop it like this, and you give it a twist. Easy as that. And then you... Well, maybe not that easy. You give it a twist. There you go, the drop spindle at work. Look at this. Now, the weight of the spindle draws out the fibers, and the twist is giving it strength. Around the 10th century, the spinning wheel arrived. But even this improvement wasn't enough when, in the 18th century, there was a greater demand for cotton, spurred on by fabulous cotton fabrics from India. British home spinners wanted to get in on the act. By the 1760s, they could use a spinning jenny, a glorified spinning wheel with several spindles. But even it couldn't keep up with demand. Anyone who could build a machine to speed the process up would make themselves a fortune. And in 1764, a barber and wig maker from the north of England, Richard Arkwright, did just that. Like the spinning jenny, his machine took the roving, the carded cotton and turned it into yarn, but incredibly quickly. It was known as the water frame, and it was run by water wheels. What a big beast it is! It is an original, built in 1771, so we're not going to get it started. It's over 10 years since the machine was last fired up, but we can still see how it works. Now here is the heart of the machine, and it's very clever. These 3 rollers, they run at different speeds. So when the roving, that's this stuff, is fed through the rollers, it's giving a little bit of stretch because the second roller is running a little bit faster than the first one, and the third one is going a little bit faster than the second one. Then finally, when the yarn is run onto the spindle, it is given a twist, locking the staple and giving it strength. The twist is all important. Without it, the yarn would unravel. The water frame was an incredible breakthrough. Suddenly, spinning didn't have to be done laboriously by hand, it could be done by machine at an amazing speed. But Arkwright's water frames were too big and too expensive for the home, so new workplaces were built to house dozens of them. The factory. This is Masson Mill in Derbyshire, England, built in 1769. It would have housed over 50 water frames, doing the job of over 4,000 hand spinners. Packed full of machinery, these mills needed serious power from their water wheels. And they got it by an ingenious system of belt drives which transferred this power across the mill. This was the birth of mass production. This machine could do the same work as 50 skilled hand spinners sitting at home at their spinning wheels. Even better, the machine didn't need spinners at all, just some maintenance, changing threads, oiling moving parts. very easy, and in those days it was considered an ideal job for women and children. And they came really cheap in 18th century England.
Arkwright built a series of mills across the north of England. This is Cromford, his first. His appetite for cotton was insatiable, as was the water frames. And to keep them satisfied, Arkwright now needed a machine to make bulk volumes of carded cotton.
And look at the result. Remember the carding brushes? You're looking at one hell of a carding brush. Now the cylinders you see there, there are bigger and smaller ones inside the machine, and they brush the material to a very fine cotton. It's called a sliver.
Teeth on the big drum brush the cotton against more teeth on the underside of the wooden slats. The old hand carding brushes had about 2,000 teeth. These new machines ran the cotton through over 4 million teeth and produced a much higher quality of carded cotton than by hand. Now, an almost unlimited supply of roving was available to keep the water frames working. Cotton spinning was now a mass production industry, but other textile industries were feeling the pinch, especially the linen industry in France and Belgium.
The price of cotton plummeted. Now that was great for consumers because they could get some cheap fabrics, but not so great for those in the other textile industries. Linen was really hit hard, although linen came from a homegrown product, flax, unlike cotton, which was imported.
The flax industry in France and Belgium had remained virtually unchanged for hundreds of years. These pictures show a very primitive flax harvest from the 1930s. And from flax came linen, a luxury product. Linen was expensive because it was hard to get the raw material from the plant. Mechanization was going to be difficult.
The trouble with linen is it sits in this stuff, the flax, and it took a lot of work to get it out. I'll show you. It sits inside the stem, or the bark as they call it. It's stuck to the outer skin by a sort of glue, the pectin. Oh, here it is. Now to soften this glue, the flax needed to be retted or soaked in water for 14 days. You could leave it out on the field in the rain, or you can load it into crates and submerge it in rivers.
And just as with pre-water frame cotton production, the work was done in the home. The retted flax was taken to workers' cottages for the next stage of the process, getting the linen out.
Now, after retting or soaking the flax, it needed to be broken, and they used a very, well, basic tool like this.
This wasn't 19th century technology. This was something out of the Dark Ages.
Then it needed to be scutched, like this. You wanted to get rid of the bark. And after scutching, you were left with this. Beautiful, soft fibers. And then finally, you could start spinning. No wonder linen was so expensive.
Thanks to the water frame, Europe was awash with cheap British cotton. Linen manufacturing hadn't changed for centuries. Could it adapt and industrialize, or would it face decline under a cotton onslaught? Britain, the late 18th century. The manufacture of cotton yarn had been taken out of the home and into the factory, thanks to the water frame, a cotton spinning machine invented by an English barber, Richard Arkwright. Cotton was cheap and plentiful. The question was, could Europe's other great textile industry, linen, survive the competition? The situation was so serious, even emperors got involved.
In the early 1800s, cotton was king, and Napoleon was so worried that the French linen industry wouldn't survive the competition
that he offered a prize of 1 million francs to anyone who could bring the industry into the 19th century. It wasn't only France that found it tough. And here in Heulen, in Belgium, you can see just how far behind cotton the mechanization of the linen industry was. This windmill here was built in 1866, and it allowed wind power to drive the flax scutching machines. Very advanced, you would say. Well, not really, because remember, Arkwright patented his water frame for cotton spinning 100 years earlier. Now, if there was no wind, you could just use one of these. It's a scutching machine, but it's operated by using your feet. Broken flax could now be scutched much quicker than by hand. Step machine, great exercise. But with wind, life was much easier in this mill. Although there was room for 4 men to scutch here, linen extraction was slow. Surely they could use the water frame to spin it. But it wasn't that easy. Linen wasn't cotton. Even after extraction, linen has a little pectin on it, the glue that sticks it to the bark. Cotton would run freely through Arkwright's machine, but linen fibers would stick together, producing an uneven yarn. And that was no good for mass production. Today, linen is spun in huge volumes on a machine invented by a Frenchman, Philippe de Girard. He was spurred on by Napoleon's offer of 1 million francs and set his mind to the problem. The answer was simple: hot water. By running the long linen fibers through a trough of water, it gave them just enough lubrication to slide smoothly over each other. After that, the linen could be drawn through rollers and spun onto a spindle just like cotton.
Now look at these machines, isn't it amazing? They still look very much like Arkwright's water frame.
De Girard developed the system in 1814, just 4 years after Napoleon had made his offer of 1 million francs.
So-called experts considered De Girard's invention. They looked at it, examined it, looked at it again, and it took so long that by the time they said this is a good thing, Napoleon was no longer in power, and De Girard, poor man, he never got his money.
Tough for De Girard, but a godsend for the linen industry. Now that spinning was mechanized, a quicker way of extracting the linen from the flax in the first place was desperately needed. It was a difficult process to mechanize, and it wasn't until the late 19th century that a machine could do the job.
The braking and the scutching was combined into one machine, the scutching turbine. Let's get a little bit of flax in it. It's right over here. Take it away.
This machine, built in the late 19th century, is part of a working museum. It provides small quantities of linen for the Belgian market. Flax is fed in at one end, then it passes through a series of rollers that do the breaking. Then comes scutching, stripping the bark off the fibers.
Inside this very dusty machine, the flax is gripped by one end and held vertically like this. And then rotating blades scutch one end of the flax like this. But then you've only scutched one end of it. So on the other side of the machine, it's turned upside down. And then the rotating blades scutch the other end. Well, something like that.
Finally, the linen comes out here, is baled and sent for spinning. Productivity is about 40 times that of the windmill, and although it's now powered by electricity, the turbine used to be run by this. A rather grand horizontal steam engine. Sadly, it's now just a showpiece driven by compressed air. With scotching now so quick, a way of providing flax for the turbine in big enough volumes was needed. In a process that hadn't changed for centuries, the flax needed to be retted, soaked in rivers to loosen the sticky pectin around the linen. And a byproduct of this steam engine provided the answer to speed up the process, not in a river, but purpose-built tanks.
Now the beauty of it was that the boiler that produced steam for the engine also provided hot water for the retting tanks. This is a retting tank. This used to be filled with flax. Now they found out that if you use hot water instead of cold water, you could reduce the retting time from 14 days to, well, a maximum of 8 days. This tank would have been filled with water to the top and then refreshed after a few days. The smell must have been horrible in here. The rotting flax. Whew.
But after all this retting and scutching, the raw linen still needs to be carded to turn it into something usable. This was much easier than spinning. Machines based on Arkwright's carding machines were developed and are still used today. Mass production had reached the linen industry, but perhaps a little too late. It never truly recovered from cotton's competition. Despite that, the age of mass production had arrived, and its effects were to become far-reaching. In a rather nice twist, the ships that carried the huge volumes of mass-produced cotton and linen were to benefit from these leaps in spinning technology.
What if these fibers once were twisted and the yarn was made and it wasn't sent off to the weavers to be woven into shirts and the like? What if it was combined with other yarns of the same kind and another twist was given? Then you would get exactly this: rope. Now, rope making, being traditionally very labor intensive, was about to benefit from the industrialization of the cotton industry. Rope can be made of flax, but in fact you can make rope out of anything. Here, tree root, this is bark, horsehair, moose skin, anything. Even, you wouldn't believe it, from toilet paper. But most commonly used is this material, and as a Dutchman I should know what this is. It's hemp.
Hemp is cannabis grown specifically for industrial use and provides strong, long fibers, perfect for rope making. But just as with linen, before you could make rope, you had to get the fiber out through retting and scutching.
And then you have a pocketful of fibers, but they need to be made into a yarn, so they need to be spun. And traditionally, they would do it with a very simple spinning device. Okay, let's start making a rope. Oh God, this is harder than I thought. Yeah, go on. Go on. I'm pulling the whole machine apart. Well, anyway, you see what the idea is of rope making. You turn the fibers and you spin them into a yarn. And, well, ideally, in the end, you'll have a rope or a yarn like this, and not like this. This is the one I made. If you twist the yarns together like this, you get a strand. And here it is. If you twist these together, that will form a rope. And in this rope, there are 240 yarns. Can you imagine how many yarns there are in this big cable here? I'll tell you, 1,632. Don't know what you can do with it because you can't even lift it.
Once spinning machines like the water frame were available, rope makers could use them to mass produce their yarns. And with a ready supply of yarn, they needed a way of speeding up rope making. In the early 1800s, an English naval captain, Joseph Huddard, came up with a steam-driven rope maker. running yarn through a register plate to a forming machine that gives it a twist. This is a direct descendant of Huddett's invention here at Alvangen Rope Works in Sweden. Now, the yarn from these bobbins pass through the register plate over here, but now look on the other side. A machine is giving the yarns a good twist to form the strand. You want to see how it works? Let's fire it up. It's powered by electricity now, but it works exactly the same way as it did when it was run on steam.
I'm making a strand right now. You can see how easy it is. Don't get my hands dirty. The machine does it for me. And I can see exactly how long the strand is going to be because of the measurements on the wall. It's a wonderful machine, isn't it?
Yarns are combined to make strands. And then, once you have enough strands, from 3 to 10 or more, these have to be twisted together to make a rope. And to do this, you have to change the gears, literally. Then hook the strands onto the forming machine and twist them together.
Now I'm ready to turn the ropes. First of all, I put this thing in place. It's called a top. And it really keeps the strands apart from each other. Come over here. Now I need to make sure that I turn in the right direction, because if I do it the other way around, everything will fall apart and I end up with yarns again. Okay, here we go. I'm ready. Ringing the bell. There we go. Well, that's easy.
Now I'm just making a short rope, but this machine could make rope 300 meters long. Once finished, the ends are cut and sealed to stop them from unraveling.
Now I've made a rope. Next I need a boat. Like this one. This is the Göteborg, originally built in 1745 and now remade to the same design.
30,000 meters of rigging went into this ship, all made a few miles upriver at Alvangen. Who would have thought that an English invention for spinning cotton would have had such far-reaching effects on trade and industry across the globe?
Mechanization of the cotton production not only fired the trade, increasing the workload of these vessels, it also led to an increased production of better quality rope, providing rigging